Oh, folks, this is the big one. How do you distinguish between commutativity and associativity? How do you tell the difference? My name is Eric Normand, and I help people thrive with functional programming. So this is frustrating for me because I get these two confused all the time. Even though I know the difference, I know I do. I could write out the difference in math, but still when I'm talking and when I, just casually going through a problem, I make mistakes, and it sucks. I think one of the problems is they are very closely associated, especially the way they're taught. The examples that are given, which are usually like addition and multiplication, don't distinguish between associativity and commutativity very well. Both addition and multiplication are both associative and commutative. So if you use them as examples, you can't really figure out from the examples which one is which. In fact, it's hard if you find a function that's commutative. It's actually a little hard to find one that to find a commutative function that's not associative. You can find them, you can construct them. They're not that hard, but it seems like most of the simple, well-known mathematical functions that are commutative are also associative. So we're going to find some. We're going to talk about them in this episode. So let's get started. Okay. So I'm assuming that if you're listening to this, you understand some of the basics of doing math with like parentheses, when you need parentheses, the order of operations between multiplication and addition, and the idea of arguments to your operators, right? So if we just have those basic ideas, we can clarify all of this. So one of the troubles is that both associativity and commutativity are about orders. Okay, that's, I like to say commutativity is about order and associativity is about grouping, but maybe that just muddles it more, because if you read on Wikipedia, they say associativity is about order of operations. So they're talking about order again. So at least for this episode, I'm going to say that they're both about order. They're both about different orders, types of orders, right? Because when we write out a mathematical formula, x plus y times z times w, then we've got different kinds of orders there. First, there's the lexical order of everything written out. We need it to have some kind of linear order, or because that's how our paper works, right? But then there's also a structural order to it. There's kind of a nesting structure. And that nesting is implicit when we write it out like that, because we have this idea of order of operations. So you're going to do the multiplications before you do the additions, right? We learned this in school. And if you're going to break that rule, so you need to do an addition first before a multiplication, you put a parenthesis around it. You put a pair of parentheses. And that indicates, do this one before, break the rule. For this one case, you're going to use these parentheses. So there's two orders, because there's the sort of the lexical written order, and then there's the structural order that you're supposed to execute the computation in. And that's the difference between the two orders. So in associativity says the order of operations does not matter. So if we look at A plus B plus C plus D, the order of operations does not matter. They're all plus. And so you could essentially draw parentheses around any way you want. You could start from the left and work A plus B and then add C and then add D. Or you could start from the right. You could start with the D and then add the C and then add the B. You could do that. You get the same answer. That's what associativity means. That you could group it however you want. You could put the parentheses here. You could put the parentheses here. You'd have the same answer. Okay. Now this works because they're all plus. They're all the same operation. Once you throw a times in there, it's not going to work anymore. You're going to have to obey the order of operations. But when you've just got pluses, you can do that. Okay, now we could also call this grouping because that's what parentheses do, right? They group the operations with their operand, right? So they group these expressions together, and they tell you this one needs to stay together. This goes first. Right? This one goes before everything else. So they're indicating the order of operations, the order that you execute the expression in. Now, commutativity is the order of arguments. Right? This is the lexical order. So if I have A plus B plus C plus D, it's a different expression to say D plus C plus B plus A, but I'm going to get the same answer. Right? I write it differently, but I get the same answer. That is commutativity. So in a simpler expression, if I have A plus B, it's the same as B plus A. You see, I've changed the order of the arguments. And that's all commutativity is. It's saying you can change the order of the arguments without changing the meaning of that expression. Okay, so let's look at an operation that is commutative but not associative. I don't want to fall into the same trap that we fall into with using plus for both associative and commutative. So with commutative, that means you can reverse the order of the arguments. Okay, any order is going to give you the same result. So here's an example, an average. So if I want to give the average of two numbers, it doesn't matter what order they're in. I'm going to add the 2 up and I'm going to divide by 2. That will give me the average of two numbers. Now, I know that this is not associative because I cannot say, well, I want the average of A and B and C, right? Like let's say I had an average operator. I can't do A, average B, average C. Why not? Well, if I took the A and the B and I averaged them, I would get A plus B over 2. And now I couldn't take that average and add in C and divide the whole thing by 2. I'm going to get a different answer from if I do B plus C over 2 and then add the A and then divide that whole thing by 2. That's not how you calculate an average. You have to add all of them up and then divide by the count, right? So we've made this average function that works for 2 arguments, but it's not associative now because of the way we implemented it. Another example is equality. So if I have something like A equals B equals C, right? Now, that's something that we write casually in math that says that A and B and C are all equal, right? A equals B equals C. But if I look at it like an operation that returns a Boolean, let's say A, B, and C are numbers. So I do A equals B, that's going to return either true or false. Let's say it's true. And then I compare that true to C, which is a number, it's going to be false. So it doesn't really make sense anymore, right? So I can't really call that associative. And you notice what's happening is we're returning a different type, right? We started with numbers, and then so take 2 numbers, compare them equal, and we return a Boolean. An associative, one of the requirements of being associative is that you return the same type as your arguments. And that's what lets the grouping happen structurally, right? If you add two numbers, you're getting another number out. And so that lets you nest them. But you can't really nest an equality check and do an equality check to that to another number. You can't do that. So, there are ways to make average and equality checks that are associative, but not they're not the typical ways you would write them. Maybe one day we'll go over those in another episode, but we're not going to go over those now. I think it's actually a pretty cool exercise. You should try it out. Okay. Now let's go over an operation that is associative but not commutative. That is, the order of operations matters. Because it's associative, the order of operations does not matter. This is a double negative, sorry. And because it's not commutative, the order of arguments does matter. Okay, remember, associativity is the order of grouping does not matter. The order of operations does not matter. And then commutativity is the order of arguments does not matter. So this one is a little easier to find because there are a lot of associative data structures, let's call them, that do depend on the order of arguments. So string concatenation is associative. It's pretty clear to see it meets our requirements. If I take two strings, I concatenate them, I get a string out, right? Very, very easy. But if I take three strings and I concatenate them, it doesn't matter how I group them, right? If I have the string A, the string B, and the string C, if I group the A and B first, I have the string AB, and then I can add the C to the end, and so that's ABC. But if I put the B and the C first, so I have BC as a string, and then I put the A on the front, then I have ABC, I get the same string out, right? But notice, I cannot change the order of arguments. A concatenated with B is different from B concatenated with A. One, I get the string AB, the other one, I get the string BA. Pretty clear. I just have to say it out loud for the recording. So this is an example of something that's associative but not commutative. Much easier to find. Another example is map merge. So map merge means given two maps, I make a new map that has all the keys of the first map, the first argument, and all the keys of the second. So it returns a new map, but it takes two maps. The reason the order matters, that you can't reverse the order of the two maps, is if there's a key collision. If map A and map B both have the same key with a different value, one of them is going to overwrite the other. And typically we make the second argument overwrite the first argument. And so that gives it an order. So you can't just reverse A and B. But it's still associative. If I have three maps, then I can group them either way. And you can try that out yourself. It's going to be hard to talk about as a recording. Okay, let me recap. Both associativity and commutativity are about order. They both say that the order doesn't matter, but it's two different orders. There's actually different orders going on. There's the lexical order that you have to write the thing out in. You know, you have A plus B plus C. The A, B, C are in a certain order. But then there's the structural order, which you kind of can impose on that linear order that says how you're going to calculate this. You can calculate from the left or from the right or from, even from the middle if you wanted to. You can break it up in two. There's all sorts of ways you can do that. And so associativity and commutativity are trying to distinguish between those orders and say when and when it doesn't matter. So associativity says the order of operations doesn't matter. How you break up this big calculation and start tackling it into smaller operations, that is the order of operations. Associativity says it doesn't matter. Commutativity says the order of arguments doesn't matter. So usually this means changing the lexical order of how it's written. So you go A plus B plus C, and you go, well, B plus A plus C, right? That you're changing the order of how it's written. And sometimes it matters, and sometimes it doesn't. When it doesn't matter, it's called commutative. So we went over two operations that were commutative but not associative. So you have average of two numbers, takes two numbers and adds them. So that's associative, right? And commutative. The addition is. But then once you divide it by 2, it's no longer associative, but it's still commutative. You're going to get the same answer no matter what order the arguments are in, but now you can't group it in the same way. Likewise, equality, it has a type change. So what you're doing is you're taking two values. I'm talking about average again. You're taking two values and you're returning an average value, which is basically a different type. It doesn't have the same properties of a measured value. Like I measured all these people's heights, and now I'm going to average them. It's a different thing, right? All right, now equality takes, let's say, two numbers, and it returns a Boolean. So that's not associative, but it's still commutative. A equals B is the same as B equals A. You're going to get the same answer. Okay, finally, we have two examples of things that are associative but not commutative. String concatenation is associative but not commutative. You cannot do the string A plus the string B and get the same as the string B plus the string A. And map merge, also associative, not commutative. Cool. Listen, if you want to see other episodes of this podcast or subscribe to this podcast, you can go to lispcast.com/podcast, and there you'll find all the old episodes, all the future episodes in the future. You will find them. There's text, transcripts, audio recordings, and video of all the podcasts. You'll also find subscribe links and social media such as email, Twitter, LinkedIn. Find me on those. Get in touch. Let's talk. If you have a comment, a question, I love to get into discussions. If you find this too difficult, if you still want questions, if it's too easy, let me know. We'll talk. And I guess that's the end of this one. So rock on.